In the third part of this tutorial, we will show how to regulate the position of this servo motor with the potentiometer. So basically, we have to know how to drive the servo motor that is connected to pin 8 of the Arduino board by means of the Arduino board. Since Arduino is a community who provides a lot of examples, we do not have to learn by memory everything. We can check for a servo tutorial Arduino, and we can find a lot of examples, also a lot of video already done. But we can start with the official Arduino website, arduino.cc. And we can have an example. If you already know how it works, this is an example where the servo is actioned by means of a push button. What we need to know is just what is the library needed to include the servo motor, that is this one. So we can copy this library in our project. The library is put before the setup. Next, we have to define the servo, choosing a name for our servo. For instance, we can call it, for instance, if it is a robotic arm, we can call it, for instance, elbow or arm. So let's call it robotic arm. It is just one axis of a robotic arm. Each axis of a robotic arm is made by one servo motor, for instance. Next, we have to say our servo, to which pin it is attached. For instance, in this case, it is attached to pin 9, but in our case, it is attached to pin 8. So in our case, pin 8 is the one who drives the servo. It is not needed, it is sufficient a digital pin, not needed a PWM pin. Okay, so pin 8 is also okay. Of course, our servo is called robotic arm, not my servo, so I have to change the name. Okay, now we have to define what angle we want for the servo. So, to put the servo in a position, depending on the value read on the potentiometer, the position that can be put the servo is between 0 and 180 degrees. So we have to do a proportion between 0 and 1023 and 0, 180. So we can say another examples. Let's go down. When we read, I copy and paste just to explain. When we read 0 volt, analog data is 0, and we want the servo angle to be 0. So we add here servo angle 0 degrees. When we have 5 volt 123, we want the servo angle to be 180, for instance. So this is the regulation. So we can say that servo angle is equal to analog data times 180.0 divided 1023. This is our equation. Okay, analog data stands to 1023, as servo angle stands to 180. So this is our formula that we can use here in our program. So we can say define a new variable, an integer variable, servo angle, that is analog, no, analog data, okay, analog data times 180 divided by 1023. And then to put the position of the servo at this angle. This function map does exactly the same thing we have done with the mathematical proportion. So we copy these instructions and oh, this is the duty. Let's put it here. Let's copy again the instruction. Copy and paste. Okay, the servo is called robotic arm. So normal my servo. So robotic arm. Write in place of value servo angle. Okay, let's run the simulation. And so we have an angle in this position. Now we put it and we see we have another different angle. Here we have 10 milliseconds is better. Here we put it to another angle, and maximum angle 180 degrees is this position of the servo. If we want to put it half position and lowest position. So you see we put the servo in the position we want by turning the LED. So this is 5 volt 180 degrees, 2.5 volt is about 90 degrees position, and 0 volt is 0 degree position, and these are the field. This is how actually are controlled robotic arms based on servo motors. So the joystick, in fact, is done by potentiometers. So when you move the joystick, it's just like moving this potentiometer, and you place the axis of the robotic arm controlled by that potentiometer in a certain position. These are the simplest robotic arms that can be done using servo because it is a very simple control. According to the position, we can regulate, and using a joystick, it is like positioning the servo the position we want. We can also check the waveform that arrives to the servo. So instead of monitoring the PWM of pin 9, we can monitor how the servo is controlled, because also the servo motor is controlled with the PWM waveform, just see, but with a different kind of waveform. So you see, if we put it at 0, we have this very low duty cycle, and we have 20 milliseconds period that corresponds to 50 Hertz. Okay, is 100 milliseconds, so 200 milliseconds, 10 milliseconds, okay. So 20 milliseconds periods that correspond to 50 Hertz. So we have a 50 Hertz waveform, and the duty cycle is changed according to the position. So higher duty cycle with 5 volt and lower duty cycle. But you see the maximum duty cycle is not 100% in this case of the servo, because it is just 2 milliseconds on and for 18 milliseconds off. When we are at half position of the servo, we have about 1.5 milliseconds input. So if we put it just 1 millisecond, just to see better. So you see, when we are half position, we have 1 millisecond and a half. Maximum position, we have about 2 milliseconds. Minimum position, we have about 1 milliseconds less, just something less than 1 milliseconds time period. So it is still a PWM waveform, but not with the duty cycle variable from 0 to 100%, but just from a few percentage, from about 1 over 20, that is less than 5%, to 10%. So the duty cycle changes from 5% that correspond to the 0-degree position to 10% that corresponds to the 180-degree position. So you see, it's very simple, and that's all. And it is the end of this brief tutorial about controlling a servo motor using a potentiometer.